back and thank you for joining us. We are starting now with the workshop presented by DRM. Digital Radio, DRM enables distance learning. The session is joined by speakers from the DRM Consortium and their industry partners. Please welcome the workshop lead, Alexander Zink, Senior Business Development Manager, Digital Radio and Streaming Applications at Fraunhofer, Germany, and also the Vice Chairman of the DRM Consortium and its Technical Committee.
Welcome everybody to this year's DBS workshop for DRM Digital Radio Mondial. It's an honor to be with DBS as every year. And we are delighted to bring you a topic that is very relevant at this time, delivering distance learning or radio schooling. And how can digital radio help with that? DRM has many benefits and tools that can allow very efficient and effective distance learning. And we want to explore today in this workshop how it is done in practice, what is the technical background, and what is required to bring it to the air. And to get started, let's have a look at the speakers of today's workshop. We start with Ruxandra Obreja, Chair of the DRM Consortium. And then the hands-on session will be managed and demonstrated by my colleagues Markus Tauber, Systems Engineer at Fraunhofer IIS, and Guido Leisker, Senior Consultant. And we're delighted to have this whole lineup of experts for you today. Let's get started and with Ruxandra introducing the topic to us.
Thank you very much, Alex, and welcome to everyone. It is a new kind of workshop for us. You are here, the first to listen to us and enjoy a new aspect of DRM. So what we are going to share with you today is a few facts about DRM. It's an explanation about what is DRM distance learning. Then we'll show you how it is done, and then you might have even a hands-on experience of this because it is a workshop. So please be ready to take notes and bombard us with your questions. So if you are new to us, let me just say a few words. All the people you have seen, already introduced by Alex, are part of the DRM Consortium. This is a not-for-profit organization with around 100 international members, big and small, broadcasters, network operators, manufacturers, and so on. The main thing to remember is that the consortium groups surely the best experts and technologists in DRM in the world, and that our consortium is open to everyone. So after this workshop, if you feel you want to be a supporter, an associate member, or a full member, please write to projectoffice@drm.org. So who is part of this family? And we have only brought a few members of the family on this slide. You will see a variety of companies you know, and others probably you are wondering what are they, where they come from. I mean, I won't go through all this. Obviously, BBC, RRI, All India Radio, Apegon, RF Mondial, Fraunhofer are all known to you, NXP, Dolby, and so on. I will just point out RF2 Digital is from Korea, your part of the world, and the Radio Diffusion is from Peru, from Latin America. So we are truly international. So why education? Of course, in this last year of COVID, which hasn't ended yet, everyone has struggled as a parent, as a teacher, as a grandparent, as a government official, with a big issue of delivering education at all levels. And the education remains absolutely essential. I think that you have here just a few quotes and the fact that education is essential. And I will just quote somebody else who is not on the slide, which said, if you think that education is expensive, wait and see what ignorance costs. So we are trying to tackle this very issue of education through the medium of terrestrial broadcast. And as we have all experienced, there has been a great challenge. First of all, most of the countries, and I won't give you figures how many, a quarter of the pupils, even in developed countries, a lot of the students haven't been able to go to school, but many more haven't had access to textbooks, to internet, to libraries, to anything. And that was part of the study life, the study day. We will tackle internet separately because in the mind of many people, when you say distance learning, okay, so I will open my laptop, my tablet, and there is my education, and I will just read it, and I am educated. It doesn't work quite like that. And I was a teacher, I can tell you. So DRM is trying to close this loop between the student and the material that exists. And it wants to not to recreate the classroom, that is very difficult, but to deliver varied teaching materials, articles, internet materials, books, but all this delivered through airwaves, not through the link and through what you know that as IP. Just here, I will give a figure. There are apparently 6.5 billion radios in the world, and about 3.5 billion people who have no access to broadband or IP. So you think about it. And we will go back to internet. This is just some information from 2020, just before COVID really started. And you will see what the penetration rate is of the internet. And you will see that although in Asia there are extremely well connected societies, actually the penetration is pretty low, and there are huge countries. It's the largest continent after all. And delivering education to every village, to every student, is a humongous, enormous task. How DRM can do it is the big question. I hope I have raised your expectations, and I am now, having done my job, I'm just passing on the baton to Alexander Zink to explain a little bit how education can come through airwaves to our students.
Thank you, Ruxandra. And let's get started right away with the basics. So as Ruxandra already explained, there is this issue with COVID emphasized over the past year, but an issue in general about students not having access to information and to education, proper education, because there is no internet, because they live in remote places, many possibilities. And just with the recent school closures due to COVID-19 and the pandemic, that was affecting over 1 billion students already, probably more by now. In general, there is a divide. If we say that all the learning material is available on the internet, that covers part of the world, but that's typically the part of the world that has plenty of access to information anyway. We are looking at the part of the world that is at the moment disconnected, or people that don't have the means, even if they have a mobile network coverage, they don't have the financial means to pay for service, because keep in mind, internet access is not free, other than radio, which is a free-to-air service. So this is one of the key benefits of using DRM digital radio for education. It is free access to everyone. Everybody can participate and join in as long as they have a radio set. That's all that's required, really. Thanks to digital radio, we now have the means to provide advanced information beyond audio. And you will see how that can help us with this use case of radio schooling or distance learning. So we can provide relevant information wherever people are without the need for any internet connection. The information that is broadcast over DRM to everybody can also be cached and provided and held in the receiver for on-demand access at any time whenever you feel ready to start your lesson and to start learning and maybe following up on a past lesson for yourself. DRM in that sense really proves to be an integrator and a universal provider of educational services and information, along with, of course, the standard features such as emergency warning functionality. So DRM distance learning, what's the purpose in a nutshell? We want to achieve a way to use digital radio, an option to use digital radio for both similar to a class-based setting use case, where you have a teacher explaining the material and you can follow that up on your own screen as a textbook replacement. But also we want to have the use case of self-study, where you can at any time tune in, turn to your radio set and start repeating the lessons, preparing lessons, just learning on your own time. With that, we will cover both the disconnect, the temporary disconnect from schools and from proper school services during the pandemics, but also solve the general issue and the remaining issue even after the pandemic of serving remote areas where people are disconnected from proper school services in some places of the world. All in all, we are looking at pure radio broadcast with all its benefits and advantages, such as being free to air without the need to pay a monthly fee. And we don't require internet coverage or data plans to pay for. This is the purpose, this is what we want to achieve. Digital radio, DRM, is the perfect platform for that. How does it work? On the one hand, we have the audio lesson. That is the classic radio program being split up into segments, covering certain topics at certain times of the day for certain class levels. That's the one element. The second element that makes digital radio special is the addition of textbook information. And for that, we have a tool called Journaline, the advanced text application in DRM. So with Journaline, we can have the content, the textual content and visualization, including graphics, available in the receivers at any time for students to look up during class, during live class session, but also at any time before or after for their own preparation. And we can provide a level of interactivity by adding quizzes on Journaline, where the solution will be shown on a later page for your self-judgment of the level of your understanding. We have Q&A sessions where we rebroadcast the incoming feedback questions from students to everybody, so that those additional questions and the answers to those questions are then available afterwards to everybody who can receive that broadcast. And there are many more forms of interactivity. It is a different form of interactivity than in a classroom, but probably an even more effective one in terms of reaching millions of people. This is the scenario how the use case looks like. So you have the studio, the broadcaster, operating a DRM content server. That's the head-end system, the audio encoder, data manager, signaling multiplexer, all of that in as the playout system of the studio for digital radio DRM. Then we have that DRM multiplex transported over the air, or over IP, to the different transmitter sites, where we are then broadcasting that content to the receivers. Within the DRM multiplex, we have the two components we already heard about. One component is the audio lesson, which is on air, live, at certain times of the day according to a schedule. And we have continuously on air the Journaline information as a radio schoolbook or textbook application. The Journaline part in particular will carry multiple components. That is the content in multiple languages for different class levels, for different subjects. And within every subject, math or language or history, within each subject, you then have the different topics for that class level that need to be learned and explained. This is an example of the user experience, how it can look like. In this case here, it's a screenshot from a mobile phone that was in use recently in Delhi at using during the trial of DRM for the FM band services, where we also showcased a radio schooling application. In the first graphic, you can see that there are, in this particular DRM transmission, multiple services, some audio programs, regular radio programs, but there's also a special education service called, in this particular demo case, AAR Radio School. Part of that is the audio that we can tune to and listen to according to a schedule. And then we have this button called Journaline. If you click on that button, you will see the next pages. So first you can select your preferred language to have access to your study content, the textbook content in your own language. Then you would select the class level that you're interested in, then the subject, and within the subject you have different topics. And for every topic you have multiple lessons and quizzes and answers and maybe Q&As and more of this information. All of this textual information is available interactively. So once the content is received in the DRM radio set, you can access it as a student at any time, whenever you feel ready for the next lesson. But of course, it also serves the purpose of a proper textbook during the live lesson on air, the audio live lesson. How that combination of an audio live lesson and the Journaline text information can look like in a demo setup is something we've prepared here. So let's use our DRM radio receiver's screen that we have here, along with the live lesson being on air. This is a video, so it's a little low volume. You have to listen carefully.
Good morning, students. Welcome to Radio School. This session is for Class 4 Mathematics. Today, we will learn about numbers in Chapter 1. Please navigate to the Journaline page, Distance Learning, Class 4, Mathematics, Chapter 1, Numbers. Please open Lesson on the Journaline. Let us start with classification of numbers. The first set of classification is natural numbers. Now we have a quiz on what we have learned today. Please turn to the next page on the Journaline. Please try to answer on your own. The answers to this quiz are in the next page for you to verify. That's it for today. Thank you.
So that was a very quick snippet and demonstration of the radio schooling, how it can look like in practice. Of course, the on-air services are much more sophisticated with much more in-depth content and information. What has not been shown yet in this demonstration, but we will see later on in the hands-on session, is that in DRM Journaline, we can also transmit images and graphics, which of course help to enrich the information and makes it more persistent to memorize. So what is the technical background? We heard about audio and we heard about Journaline so far on the DRM platform. For audio, the choice is clear. We use the most efficient audio coding that is available at the moment, called XHE-AAC, the audio codec that starts giving speech services starting at 6 kilobits per second, just to give you an idea. The other key features are that you must be aware of in DRM is you have multiple programs per transmission, excellent audio quality up to surround sound, the good coverage with SFN single frequency networking option, the automatic tuning, and the emergency warning functionality. Most of these you have already seen on the screenshots before. We want to focus now on the multimedia applications in particular and how they can help us to enrich the radio schooling and make it possible, the radio schooling use case. We have a handful of standardized data applications, multimedia applications in Journaline, from the little scrolling text that gives you the currently playing song title and artist, to a slideshow for the local services with higher capacity, where you can show the album cover, for example, of the currently playing song. You have the service program information for the station logos and EPG information, and you have traffic. As I mentioned before, the one element that is relevant for us now for the radio schooling use case is Journaline, the advanced text application, interactive text application in DRM. Journaline in general is like an electronic newspaper. So we transmit the different pages and the menu structure that make up the Journaline service. The structure to be used, the type of information to be provided, is completely up to the broadcaster. And this powerful flexibility allows us to use Journaline, as you can see here, as an audio example for news and sports updates and business information and program schedules. But we can also use it for radio schooling purposes. Journaline, like every text component in DRM, supports Unicode, so you can transmit any language that you want to transmit and make available. The types of content are listed here. You have general information and program-related information, and part of the possibilities for general information are distance learning, education, or radio schooling applications, the ones that we're using today. Some technical benefits of using Journaline and why it is so suitable for DRM is that it works at very low bit rates. The information that we are sending out is cached in the receiver, and once all the content is received, you technically wouldn't require the reception anymore. Then the reception is purely for updating certain pages in your cache with the latest information if there are any changes. Otherwise, the whole Journaline content body is available for immediate interactive access, navigating through the menus on the receiver. On the transmission side, it uses existing data sources. It's a very simple text-based format called XML that we use to create this menu structure and the individual pages, including links to images. If you've ever seen HTML code before of a web page, then basically that's the same for Journaline. On the receiver side, we use Journaline supports very inexpensive consumer receivers because it doesn't have any specific requirements regarding CPU power, memory, or the screen size. It can work even with a few text lines if needed. For the special use case of radio schooling, we are now working with receiver manufacturers for DRM receivers that will have a built-in Wi-Fi hotspot. So you receive the DRM transmission, the content, the Journaline content is cached in that receiver device, the Journaline is decoded in that receiver device, the audio is decoded there, and then it opens up a Wi-Fi hotspot for local access. So if you have any Wi-Fi enabled device surrounding that receiver, be it a mobile phone, feature phone, tablet, even a modern TV, a PC, anything that supports Wi-Fi, you can access individually the full content for your radio lesson being received on that central DRM receiver, but you only need a single receiver to serve either a full household, a community, a local community, or a classroom setting. A very useful and innovative way of receiving and making DRM services available to people. Now let's have a look at the in-depth technical background of how we achieve the radio schooling services. If you look at the flow of content from the broadcast side to the receiver and what goes into it. First, we need the first group of participants, the experts, the teachers, maybe ministries, whoever is responsible for learning material in your country. They are already working to create lessons and textbooks today. And that will have to be adjusted, implemented, or improved on for digital radio features to be converted. For example, the existing textbooks being converted into Journaline format. That's a very straightforward way. Or it could be content that is specifically created for the radio schooling in DRM. So that's the first group, experts. The second group is the broadcaster or service provider, who defines the overall Journaline structure, which languages need to be included, which class levels should be supported, which lessons, topics, and so on. Then the material that is provided by the experts is converted into that Journaline XML format. The broadcast is configured and it's put on air. And finally, for the listeners, we look at the access to that Journaline content that can be a built-in nice screen into a receiver, which of course comes with a price tag. But there are solutions for that, or it can use an innovative approach such as the DRM receiver with a built-in Wi-Fi hotspot that I explained just earlier. And in any case, the purpose is that students as well as teachers can access that information at any time while the audio lesson and in the audio track is going on, the live lesson, or at any time before or after that. So let's now look at what needs to be done from a broadcaster's perspective, because I assume at DBS, this is our main focus. How can we, on a technical level, enable DRM digital radio services? Let's keep in mind, and as a reminder, what the user experience is. On the left side here, you see the audio service that is being placed on air and prepared along with the textual content. On the right side, you see the textual content, in this case, consisting of a menu structure with the language selection first, then the class level, then the subject, and then the different topics within that subject. This is the static content, the textbook content in Journaline. And then we can think about options to make the service, the radio schooling service, interactive by having a phone-in Q&A for students, for example, with a rebroadcast of the answers and questions to everybody through Journaline. We can have quizzes and solutions, as you have seen in Journaline. We can link to online resources. If somebody has an internet connection, of course, they can make use of that and find additional background information, probably. And student comments in general. All of that can be rebroadcast, made available as a living Journaline service beyond the static textbook information. If we look at the DRM transmission chain as an overview, on the left side, again, we have the studio with the DRM content server, taking as an input all the different audio sources, the radio programs, but also our pre-recorded or live educational lessons. And then we have the data inputs, multimedia content, such as Journaline and all the other information. That's then distributed to the different transmitter sites and being transmitted on the over the air. So how can we interact with these components? On the transmission side, working as a studio or as a content provider, we use this tool called the DRM content server's web interface. This is the same web interface that you will see in a moment in the hands-on session that is also used by the broadcaster. So in our example, we now have the content created by the experts, the teaching material, textbook material, and we have converted it into the Journaline XML format, and now we want to put that content on air. And you will see in a moment how that's being done through that simple web interface of the DRM content server. So keep in mind, once you see that web interface on the screen in a moment, that represents the broadcaster's perspective. And then, of course, we also need to look at the receiver's perspective. How does it look like on the receiver side, our service that we are transmitting? For that, we have a tool called the DRM Multimedia Player radio app. That takes the MDI, the multiplex information from the studio to the transmitter, and it can receive and decode that same MDI format as if it was a live receiver. We are just bypassing the HF part for that, the RF part, the on-air part. But otherwise, it's a fully working DRM receiver decoding the content server's output live as any DRM receiver would do. So these are the two components you will see during the live hands-on session. On the left side, the trans side or the studio side represented by the content server, and on the right side, the DRM multimedia player receiver app that gives us decoded content and represents a DRM radio. And with that, I will now hand over to my two colleagues, Markus Tauber and Guido Leisker. Guido will start the introduction to the hands-on session, and I'm sure that's the part you're most interested in.
Yeah, thanks, Alex, for handing over to us. In the next couple of minutes, we will have a quick look on how such a distance learning service could look like. Could you, next slide, please, Alex? Yeah. You have already seen in the video how it could look like on a receiver side. Here, you will focus on the source content could look like before it is fed to the DRM content server. And we will also show you, as a practical example, how to add an additional class lesson to the existing service. Can you go back, please, Alex? During the live example, you will see the broadcasting side on the left-hand side. This is a view of the web interface of the DRM content server. The DRM content server is the DRM headend where audio and data is provided to and which does the encoding and multiplexing. The output of this system is then forwarded to the transmitter for the on-air broadcast. On the right-hand side, you will see the DRM multimedia player up, which serves as an example for a DRM receiver here, just as you have seen before in the video. So in a nutshell, on the left-hand side is a broadcast transmission or sender side, and on the right-hand side is a receiver side. Next slide. But before we start with a live example, I would like to point out a few essentials that are important to allow you to follow. A service component is what is presented as a service to the user. So here we are focusing on a Journaline service, as that will contain the content for our distance learning. Such a service can then be selected by the user on the receiver for consumption. After the selection, the user navigates through the content. Technically, each Journaline service component can be composed of one or multiple content providers. In the general example on the slides here, those components might be news or an extra component for COVID-19 information and updates or sports. These providers, in this example, also reflect the hierarchy as it is presented on the receiver side on the right. But technically, any provider can be inserted anywhere in the hierarchy. For our example, distance learning, those components might be different languages, different classes, or maybe simply from logical separated origins. Technically, there are several ways to provide or fetch content for Journaline. One possibility is to configure the content server to fetch content from RSS feeds from the web automatically. This is a very easy way and fast to set up. So just using existing content that is available on the website anyway, but now without the need for internet access for the listeners. Another possibility is to provide Journaline XML files to the content server. The Journaline XML is a standardized format which can be generated manually by the content creators. There are plenty of tools for users for manual creations. And there are also tools and libraries for virtually all environments to work with XML. Thus, the Journaline XML can be automatically or semi-automatically generated from playout systems or content management systems. Here, we will focus on the XML file approach, the manual way. But please note, for regular usage, there will be tools in order to prevent teachers from setting up these manually. So next slide. So soon, Markus will start the live example. Markus will initially show what is on air currently and how the source files for this content look like. He will then add an additional math lesson to the existing content. He will therefore have to edit the existing, almost empty template provided for this lesson. And as a final step, he will add graphics. Of course, graphics are really helpful for the students. And we want to show you that it is possible and even quite straightforward to broadcast graphics with the Journaline service. So, Markus, take it on from here.
Yeah, thank you, Guido, for that wonderful introduction. And hopefully this makes it much easier for you now to follow the live hands-on session. Let me start by first explain you again what you can see now on the screen that is shared to you. So on the left, as explained earlier, you have the broadcaster's perspective. You can see the web UI of the Fraunhofer DRM content server, currently showing the service component editor, and focusing in the middle on the Journaline component for distance learning. And on the right, you see the listener's perspective from the multimedia player. This could be, for example, a student in a remote area or in homeschooling who is listening to the live broadcast and gets this program in his receiver. So what we did is we have a service that is named Radio School that contains both audio and the Journaline service component for live distance learning. And then we have just a normal audio service containing some entertainment listening songs. And then again, we have the Journaline content as data service only for remote learning without audio, which can be available even without a live lesson schedule. So let's dig into the Radio School, and I open the Journaline page. So first of all, you can select different languages. And to make this example as easy and minimal as possible, we only focused on a single language for the moment, English, and all the other languages here are just placeholders that, if you click them, do not contain any data at the moment, but you could easily just add new languages if you have the content prepared prior. So to show you the structure, which is what you can see on the right, how it reflects on the broadcaster side, let me show you these different providers here in the Journaline component. And you can directly access the XML content from the content server. And this is what it would look like. You have an XML-based structure, as explained earlier. You have different items, menu items and item labels for the languages. And for all these additional languages, we just made placeholders and wrote that this page is under construction. So only for English, we actually implemented something. And if I open that English class, that would be then structured here on the left in a different provider. So this was the master content provider who combines all the different providers and makes a proper structure from all the content. And here then, one level deeper, we have this class 4 XML structure. And again, I can show you quickly. And here, sorry, this is not the right component. So let's go one level deeper here in class 4. Then here you can see the structure of the different topics. Also here we only focused on mathematics and haven't implemented something for science and environmental studies. But I hope you get the idea. So inside mathematics, in the video before, we had these two topics, numbers and equalities and inequalities. What we did for this live session is we added an additional topic, topic 3, Pythagorean theorem. If you open this, this is currently not implemented. This is just a template. I can show you this on the left side again. Here in the web view of the XML, you can see that there is a basic structure, title of the topic, then a lesson menu item, some quiz and answers again, and all this is still not filled. So in order to speed up this process, of course, I have prepared this content in advance and can just copy these different parts directly into the web UI of the content server. In between these text sections, I do this for the lesson. I can do this then for the quiz. And of course, also for the answers. So What we forgot is, or what I forgot is, to change the topic. This should be topic 3, the Pythagorean theorem. So when I press this button, what will be done is that the content server, that the data is uploaded to the content server. The content server will check if the data is syntactically correct and will complain if it's not, if there are any errors. And as soon as this is completed, it will immediately transform it to the proper broadcast format and will then put it on air. So let me press this and show you. So of course, we will not have any errors indicated by this message. And now on the right, what you will see is in a few moments that there is an update. So the teacher, the student can still see the old content if there was any, but can then decide manually to load the update, and then he will get this enriched service. I can show you also the quiz and the answers. So since it is said that the picture says more than 1,000 words, and also this lesson here is referring to a picture, of course, it would be useful to have this picture in the Journaline itself. So what I will do is I will just open up this web view again. And of course, I also prepared this in advance. There are several ways to add pictures to Journaline. We could elaborate later the several different ways, but what I did for this workshop is I used the approach to directly embed the picture as base64 encoded content. Let me just show you and explain afterwards how you could achieve that easily yourself. So basically, the image is contained in that single line. It's very long, but it doesn't matter because you will not see this line on the receiver. You will only see the you will see the picture. And let me add this here. And also I have another picture for the quiz. And I will also upload this here. And again, we'll start the upload process, and the content server will tell me if everything is okay. It is. And now quickly go open the receiver's perspective again. You will see an update again. And then now this picture is contained. This picture is possible because this is saved as an SVG, which is very low in data and still allows for sharp images in different ratios. And here on the next page, I have uploaded a PNG, which is also possible. So actually, SVG, PNG, and JPEG are possible, but preferred, of course, is SVG, scalable vector graphics, because it's the lowest in data. And keep in mind that Journaline is intended for text services in its main priority. And that's why we need to make sure that these graphics we use are very small and in size. So how do we get from that picture to that space 64 encoded picture? So there are actually several services available online. You can just Google for them. There are different ways. This, for example, is a web page which just allows for any type of image. And here, this page allows for PNG services only. I will use this page quickly just to show you how it would look like. We have here the PNG image of this triangle. And I can just manually put it here. And then you have this base64 encoded replication. So, of course, a teacher should not bother about that at all. And but as an expert on the broadcaster side, that is easily done. So basically, what I wanted to show you with this hands-on session is, given that a basic structure already exists for this Journaline distance learning, it is easy to just update it with additional classes and additional lessons and also additional languages. And basically, the teachers just need to provide the broadcasters the proper learning material and graphics, and then this can be easily and done, and within minutes, the new lesson could be on air. So that's it from my side. I hope you could follow me, and it was comprehensive. If time allows, we could also show how easily you can switch the complete distance learning content by just changing the on-air broadcast, because in these examples, the on-air configuration did not need to change at all. It just put the content to the content server, and the on-air configuration didn't change at all. But it is of course also possible to change the on-air configuration to quickly change the whole content quickly for also different classes, different topics, and so on. But that's it from my side for now. If time allows, we can show later also content targeting an African area. So let me hand back to Alexander Zink or Guido to sum up all we have heard today.
Thanks, Markus. That was very visual, and I hope that the message, how easy it is to prepare content for DRM transmission, to convert it into the appropriate text-based format, and then to transmit it, how you structure the service, all of that is now a bit more understood, and it is clear how relatively easy it can be done. As we said earlier, as a quick recap, keep in mind that the special solution using DRM digital radio for radio schooling, for educational services, is that we do not need internet at all. This service works as long as you have radio reception. You don't need mobile coverage, and even if you have coverage, you don't need to pay for a data plan. People who can't afford that can still receive the free-to-air services. That aside, to be clear, of course, DRM allows you to link in a hybrid way the broadcast services free-to-air for everybody with individual links to certain web pages online if you have an IP-connected, internet-capable radio set. But that's an option. The actual core information that you've seen, the audio lesson and the Journaline textual information, is all broadcast as part of the on-air radio services. And that's the key benefit of using DRM for educational services. It's that free access to information for everybody. We're using the digital capabilities of digital radio to provide this relevant information that goes way beyond audio by linking up the audio component, the live teaching lesson at certain times of the day, with the textbook information via Journaline in multiple languages, available at any time for the students on the radio set. So no need required for internet connectivity. Also, no need to keep your radio tuned constantly. You have to keep it tuned while the audio lesson is going on. There is the option, depending on the radio set, to record those lessons based on a schedule. That's an option, but that's a receiver-specific option. Otherwise, the DRM Journaline content is available all the time. I think it shows as a nice use case that DRM really can act as an integrator and universal provider of information, particularly also bringing educational services to people in remote areas, and specifically today to people who are disconnected from regular school services due to the pandemic. A great opportunity and a great use case. Now, so much about the basics. I hope it was of interest to you, and maybe you learned something new in this workshop, and maybe it excited you enough to really start working towards such a radio schooling service in your own broadcast environment using the existing infrastructure. If you want to learn more about the technical background and how DRM works in general, I suggest you have a look at the DRM handbook, which is now available as version 5 as a free download from handbook.drm.radio. Just go to that URL and it's a free download available to you. If you want to get in contact with us, there's always the homepage, drm.org. I strongly suggest, if you have any interest in digital radio DRM, that you subscribe to the monthly newsletter. The easiest way to access that is newsletter.drm.radio. If you are from India and interested in what's going on there, in particular, there is a dedicated India page also. And for any questions, be it membership, technical, demo cases, or just help with setting up an educational service on DRM, please write to projectoffice@drm.org. And of course, follow all our social media channels if you're interested. Now, that was plenty of information, and we have received quite a number of very interesting questions, and I think we do have the time for a few of them to be answered. So let's get started with the questions.
I read them, some of them, of course, because I was listening to this very interesting presentation. And I just wanted to make just a few points. I mean, all the questions are extremely interesting and we will answer them. But there was one particular one which was mentioning that actually we are trying to do through DRM and Journaline what is already available on other standards. And I want to make very clear the point that, of course, digital radio has extra benefits. It doesn't matter which standard. What we are doing is we are showing how it can be done. I haven't seen it done by any other standard. And the other thing that we are also saying is that because DRM works in all the frequency bands, that's how you are going to reach the remote villages, students who are, I don't know, somewhere in a rural area, because DRM works on shortwave and medium wave and FM very well as well. So if you are comparing what could be delivered, because I haven't seen it yet, through other standards and what DRM does, I think we offer, even in education or also in education, a complete solution, a complete country solution, because pick up, do mathematics class 4 in English and other languages, then you have the teachers, as Alex explained, you have the whole transmission, which is you have to program, but you could broadcast this to the whole country. I think that is quite unique. That's my answer to we could do that. Is DRM catching up with other standards? No, we are not catching up. We are leading the way. And if you have seen it in other standards and you think it can be done with IP, and it can be done on expensive receivers. A receiver with a proper screen to see all this, whether it's DRM or any other standard, will be expensive, my dear, no matter what, no matter where. Okay, right. That was an answer to one or two questions, but there were other very, very interesting questions about XHE, I think, code, and about hardware, and more general, whether it can be done in band 1.
Mm-hmm. Yeah, so let's try to go through them, but also in addition to what you just answered, the general question, DRM radio schooling distance learning is not about replacing any of the existing services, certainly not live school where possible, and also not internet services. It's an additional opportunity for people and using as many play-out ways to reach people as possible. And there are people who cannot benefit from internet services, who, at least at present, but maybe in general, cannot participate in live school sessions. And those are the people that then DRM can help reach. So that was about this question. Now we have plenty of more technical questions, and let's go through them and try to address them. Will receivers be able to render SVG images? And the answer clearly is yes, if you have a modern receiver, or if you use the Wi-Fi approach that we mentioned, where you use an existing web browser to access the information, all of them can do SVG images today. Then there was a question about connecting a full LCD-enabled receiver with the internet, and that would be very expensive. I guess that comes back to Ruxandra's answer already. There is the possibility to have a back channel through the internet, but the radio schooling application works as a broadcast-only service. You don't need internet. And the question about the big screen to access the Journaline information, that's one way of accessing it in a DRM receiver. But another way, even without any screen, would be to use that Wi-Fi hotspot feature and using another screen device that you have available locally to connect and access that received content. Again, without the need for any internet connectivities. Do you need extra hardware for educational services in DRM? Well, you need a DRM receiver, but beyond that, no additional hardware is required depending on the type of receiver. If the receiver has a built-in screen, you can use it as a personal device at any time. If you have more like a school setup, classroom setup, or a community setup, or a family setup where multiple people want to access this information simultaneously with their individual pages and navigation through the content, in those cases, the Wi-Fi hotspot feature makes more sense, where the digital radio signal is received with a single DRM receiver, and then access to that information is shared among multiple people around that using the Wi-Fi hotspot and any Wi-Fi enabled device that has a web browser built in. But no internet required, keep in mind. Then we have a question about XHE AAC for the DRM radio transmissions and royalties, and wouldn't it be cheaper for broadcasters to use another audio codec? Well, to answer that question, if you buy a transmitter today, an FM transmitter for a few $1,000s, if you buy a medium wave transmitter for a few $100,000, the actual cost of the XHE AAC royalty, the encoder, is 97 cents one time. I don't think we need to discuss that question. Oh, by the way, for some Asia-Pacific countries, the royalty is even lower because they have a special rate. So it's in the range of 70 cents one time per that transmitter. There is no running royalty for using XHE AAC by the broadcaster. It's just part of the equipment. The same way XHE decoding is part of all the modern Android, iOS phones, tablets these days. It's a built-in feature. And you as a user, you don't care about the royalties. That's all taken care of. Then we have the question of when is DRM coming to Malaysia? Will it be available in Malaysia? Ruxandra, do you want to answer that one?
Good. I get all the good ones.
Yes.
Listen, we would love to see Malaysia really looking seriously, and I know it is, at DRM, and we would love to see a commitment from the ministry and from the regulator. And let me assure you that I think that your country, beautiful country actually, with its, what shall I call it, a very unique shape, is made for DRM. And why couldn't we do education through DRM? So the answer is we are ready. We know that the Malaysian authorities are looking favorably at DRM. We are just waiting to see if this becomes policy. And once it becomes policy, then the receivers will be available. Let me address receivers, because there is a question, a sort of pointy question here about, oh, there are so many more receivers of this particular standard, and why is it more popular? Is it more marketing and so on? My simple question is, please do not how shall I say, compare India with any European country, because it's laughable. Delhi itself has 22 million people, which is about 4 Norways. So let's not go down that route. I think there is a standard with all the benefits. All the standards are good, but they have to suit the needs of a particular country. So the receivers will come when the policy is there, and there are already all sorts of models. The prices are going down in India. There are models we have shown during our recent India trial. They can be acquired on Trade India, Amazon, and so receivers are coming in numbers. There are not millions, unless we talk cars, about 3 million cars in India. But DRM is a younger member of the digital radio standards, is more flexible and covers more. So we have to accept what has been achieved by others, well done, and have total trust and encouragement for what is new and where the new things come for these times. The times have changed. Look at other solutions. So Malaysia would love to work with you. Malaysians, please, please, please get DRM for education, but also for audio and for text, for everything you need, all the information you need, and for disaster warning.
Mm-hmm. Thanks a lot. And the last question, because that came up twice, I believe, was about the application of DRM transmissions in the FM band. That's one of the unique benefits, that you can use the white spaces between existing analog FM services and add digital radio signals for the existing broadcasters there to step-by-step migrate over to digital without sacrificing the analog FM services in the beginning. That is a possibility. The question was about 100 kilohertz center-to-center spacing. That's not possible, because DRM has a bandwidth of 100 kilohertz. FM has 200. So if I have the distance at only 100, they would be overlapping. That's not an option. The minimum distance is 150 kilohertz. That is possible and has been demonstrated in Delhi extensively if both signals come from the same transmitter. With 2 signals from separate transmitters, the minimum distance still is only 200 kilohertz, and then you're really flexible in the digital power level compared with the analog FM. So there is definitely an option, and then depending on the width of the gap between 2 FM services, you are flexible in adding multiple DRM signals from individual broadcasters, but sharing a single FM transmitter in between those ongoing FM services. And also keep in mind, when it comes to receivers, millions of cars are on the road in India with DRM built in. That and mobile phone reception are the key ways of listening to radio. It's not so much the desktop radios anymore in India, and therefore you don't see that huge number of models. But for the cars, there's a huge success. And for mobile phones, DRM in the FM band is actually the only standard that can make use of the built-in FM RF front end. So without any hardware changes, just by adjusting the software options on the phone, manufacturers in future can support digital FM DRM in addition to analog FM. So much about the questions. Thank you very much, everybody. I hope we could answer most of your questions at home. If not, feel free to ask more questions, and then on your radio, ABU will collect them and forward them, and we will try to answer them as quickly as possible. Always write to projectoffice@drm.org.
Yeah,
Ruxandra,
right
you had?
No,
Yeah,
I just
write to us, Project Office.
Yes, we are all there, and we thank you very, very much. No question too hard, no project too hard. So we are open to you. Join us, Let's work together.
Thank you, Ruxandra. Thank you, Guido, and thank you, Markus, for that great hands-on session.
Thank you,
And
everyone.
with that, I hand back to ABU.